Okay, hello, we welcome you back again. This is Physical Sciences Silver Bullet, and it is Richard behind the channel. If you have not yet subscribed, we urge you to do that. Yeah, it is to your advantage. Okay, now we are looking at this question. It's a continuation of our part 1. Okay, it says consider the reaction of sulfuric acid and water taking place in 2 steps as shown below. So what do we have in the first step? We're having sulfuric acid reacting with water to give you hydronium ion and a bisulfate. And in equation 2, the bisulfate comes and it reacts with water to give you hydronium ion and the sulfate ions. And the first question comes. It says, define the term ampholyte. What is an ampholyte? An ampholyte is a substance which reacts as an acid at one point and a base at another point. So it can react as an acid and a base. That's what we call ampholyte. Okay, after that, then comes this question 1.5.2. The question says, write down the formula of a species that can act as ampholyte in the equations above. Now, remember we said ampholyte can behave as an acid or a base. It can flip its behavior. Now, when you look at the first equation, let us look at the first equation. Okay, we're having this one as and the acid, and this acid as its conjugate base, this one. So we are having this one as the acid and this one as the base. Now we have this one as the acid and this one as the base. Okay, then we come to this side. We are having this one is the one which is donating a proton here to get hydronium ion. So this one is the acid and this one receiving the proton is the base. This is the acid, this is the base. So when you examine that one closely, this is what you realize, that this hydrogen sulfate or bisulfate, in this reaction, it was a base. And when we came to the equation number 2, it became an acid. So that means that it can act as an acid or a base, meaning that it's the ampholyte. So that's that. So we go to next question, the next follow-up question on this one. Okay, then comes this question. It says, identify the conjugate acid-base pairs in the equation 1. This one happens to be our equation 1. And let us explore what actually is taking place here. We're having this acid and we are reacting it with water. To assess this question, you have to use the Lowry-Bronsted idea. Our acid here is donating a proton to the base. Remember, according to Lowry-Bronsted, an acid is a proton donor and a base is a proton acceptor. So this acid donates a proton, one of the hydrogen here, to this one. So when this base, which is our water, receives a positive proton, it becomes an hydronium ion here. And after losing a proton, what we form is this one, the hydrogen sulfate ion or bisulfate ion. Now you have to know that the difference between an acid and its conjugate base is only one proton, which is possessed by the acid. So when you look at this case of ours, when you look at this one, this is our acid, and after donating the proton, it became this one. So this one is the acid, and this one is its conjugate base. I repeat, the difference between the two is one H, one extra H possessed by the acid. Okay, let's also assess this side. Now, this is another pair we have. When water gained a proton, it became an hydronium ion. This one is another acid we have. And the difference between this acid and its conjugate base is 1H, which this one possesses. So this is the acid, this is the base. And for this pair, this was the acid, this was the base. So those are the pairs we have, and let us write them down. So these are the pairs. This side we have the acid, and that side we have its conjugate base. This is the second pair of conjugate acid base pair. Okay, let us now go to the next question. Then we come to this question 1.5.4. It says that for equation 2, write chemical formula of two bases. Okay, let us look at the equation and analyze it. So what do we see here? This is the equation 2 we are talking about. We are having hydrogen sulfate reacting with water to give you hydronium ion and sulfate ion. Like I said, we follow Rayleigh-Bronsted. This one donated a proton to water. Water, after gaining a proton, it became hydronium ion. After losing the proton, this one became this. So remember, what does Rory say? He says that an acid is a proton donor. So because this one is the one which donated the proton, it is the acid. And because this one received the proton, it is the base. Now, you have to know that if this is the acid, the one which has less one hydrogen is supposed to be its conjugate base. So which is this one? So this is the base. And we say if this is the base, the one which has one extra proton is going to be its conjugate acid. And this is it. So what are we going to give for this answer? The two bases are already identified. It's going to be water and sulfate ion. Okay. Then comes this question, writing the formula of the two acids. This one has been already answered. Remember, the acids are bisulfate and hydronium ions. So those are the two acids. Let's go to next question. Okay, now this comes Another question, it says, write the formula of the conjugate base of hydronium ion. Like I said before, the difference between a conjugate base and its conjugate acid is 1H. The conjugate acid has one extra H, which the base is missing. So when you look at here, this is what we are talking about. And if you take out one H, this compound becomes what? It becomes water. So H2O is the conjugate base of hydronium ion. Okay. Then we come to the closing question of this video. The question says, write the formula of the conjugate acid of sulfate ion. So this is what we are having. So when they say write the formula of the conjugate acid altogether, it means that whatever you are talking about, this one is a base. That's what it means. Write the formula of the conjugate acid of this, which means that whatever we're dealing here is a base. And remember, the difference between a conjugate acid and its base is one proton, which an acid is having. So what do? You just add one proton to this one. Whatever it becomes is the conjugate acid. So when you add one proton to the sulfate ion, it becomes this. So hydrogen sulfate or bisulfate is the conjugate acid. So we are closing this video here, and if you have not subscribed, please do so. So we meet again in our part 3 of this question. Thank you for being with us.